Welcome to G Fun Facts Online. Today, we're talking about a machine that looks like it was pulled straight from a golden age science fiction novel. A towering behemoth of stainless steel, born from a relentless cycle of explosive tests and audacious ambition, is poised to rewrite the rules of space travel. SpaceX's Starship, the most powerful rocket ever conceived, isn't just an upgrade to what we've seen before. It's a revolutionary leap towards a future where humanity's reach extends far beyond Earth. This is the story of a machine that promises to make interplanetary colonization a tangible reality, turning the final frontier into a bustling highway for exploration. At the heart of the Starship program is a single driving goal that has fueled Elon Musk since he founded SpaceX back in 2002. To make humanity a multi-planetary species. This grand vision is being forged into reality at Starbase, SpaceX's sprawling facility in Boca Chica, Texas. Here, a rapid-fire approach of building, testing, and often spectacularly failing has accelerated the development of a fully reusable space transportation system faster than anyone thought possible. The Starship system itself is a two-stage vehicle. It consists of the Super Heavy booster and the Starship spacecraft, which sits on top. When fully stacked, it stands an imposing 121 meters, or nearly 400 feet tall. But its size isn't the most revolutionary part. Unlike any rocket before it, both the booster and the spacecraft are designed to be fully and rapidly reusable. This is the key innovation, the very cornerstone of the reusable revolution that SpaceX began with its Falcon 9 rockets and is now aiming to perfect with Starship. This reusability is what promises to drastically slash the cost of getting to space. Let's dive into the radical approach behind this machine. The first thing you notice about Starship is its gleaming stainless steel hull. This is a major departure from the carbon fiber composites used in most modern aerospace projects. SpaceX initially considered carbon fiber but made a pivotal switch to a custom stainless steel alloy. Why? The material has incredible strength at both the freezing temperatures of cryogenic fuel and the scorching heat of atmospheric re-entry. It's also relatively cheap and easy to work with. The rocket's body is built by stacking and welding massive steel rings, each about 6 feet tall, allowing for incredibly fast production and iteration. Powering this colossal machine are the equally revolutionary Raptor engines. These are the first full-flow staged combustion engines to ever fly. It's a complex and highly efficient design that burns a combination of liquid methane and liquid oxygen. This choice of fuel is strategic. Methane burns cleaner than traditional kerosene, but more importantly, it can theoretically be produced on Mars. Using atmospheric carbon dioxide and water ice from beneath the Martian surface, future colonists could refuel starships for a return trip to Earth. This concept, known as in situ resource utilization, is crucial for the vision of a self-sustaining Martian colony. The Super Heavy booster is an absolute monster, equipped with 33 of these Raptor engines, generating a staggering amount of thrust to lift the entire stack off the ground. The Starship upper stage, which carries the crew and cargo, is powered by 6 Raptor engines, 3 for atmospheric flight and 3 optimized for the vacuum of space. Now for one of the most visually striking and technically daring parts of the mission, the landing. After its mission, the Starship spacecraft performs what's been nicknamed the belly flop maneuver. It reorients itself to present its broad, heat-shielded side to the atmosphere, using 4 large flaps for aerodynamic control, much like a skydiver. This slows the vehicle down from orbital velocities before it performs a final dramatic flip to a vertical position for a powered landing. Protecting the vehicle from that intense re-entry heat is a thermal protection system made of thousands of hexagonal black ceramic tiles. The durability of these tiles has been a major focus of the testing program. Each test flight brings new data, leading to refinements in how the tiles are attached and designed. But perhaps the most audacious part of the whole reusability plan is the chopsticks catch system. Instead of landing on legs, the launch tower itself is equipped with massive mechanical arms. The plan is for these arms to literally catch the returning Super Heavy booster and eventually the Starship itself right out of the air. This eliminates the need for heavy landing legs on the vehicle and allows it to be placed directly back on the launch mount, ready for a rapid turnaround and another flight. The journey to get to this point has been a public spectacle of rapid prototyping and learning from failure. The development philosophy embraces what's known as iterative design. Build something, test it, see what breaks, and use that data to build the next one better. The story really began with Starhopper, a short, water tower-like test vehicle. In 2019, Starhopper successfully performed a series of hops, including a final untethered flight to 150 meters, proving the basic design and the Raptor engine worked. After Starhopper came a series of full-scale prototypes with serial numbers like SN8, SN9, and SN10. This phase was marked by a series of spectacular high-altitude tests. Prototypes ascended to 10 kilometers, successfully demonstrated the belly flop maneuver, but all ended in crashes or explosions during the final landing sequence. While they looked like failures to the public, each fiery end provided invaluable data for the engineers. The major turning point came in May 2021 with prototype SN15. Incorporating all the lessons learned from its predecessors, it successfully completed the high-altitude flight and, for the first time, achieved a soft, vertical landing. This success paved the way for the next phase, full-scale orbital flight tests. The first integrated flight of a full Starship and Super Heavy stack took place on April 20th, 2023. While the rocket cleared the launch tower, it suffered multiple engine failures and didn't achieve stage separation, leading to its intentional destruction. However, subsequent orbital tests have shown remarkable progress. We've seen successful hot staging, where the upper stage engines ignite before the booster separates. We've seen the ship reach orbital velocity. And in a landmark achievement in October 2024, the fifth orbital flight saw the first successful recovery of the Super Heavy booster by the launch tower's chopsticks, a breathtaking maneuver that proved the core concept could work. So what is all this for? The revolutionary potential of Starship lies in its intended missions. First up is returning to the moon with NASA's Artemis program. SpaceX won a multi-billion-dollar contract to develop a lunar-optimized version of Starship to serve as the human landing system. For the Artemis 3 mission, planned for no earlier than 2027, astronauts will travel to lunar orbit aboard NASA's Orion capsule. Two of them will then transfer to a waiting Starship HLS for the final descent to the moon's south pole. This lunar Starship will be enormous, with more livable space than the entire International Space Station. A critical part of these lunar missions is a maneuver that has never been attempted on this scale: in-orbit refueling. Before heading to the moon, the Starship HLS will need its tanks topped off in low Earth orbit by a series of tanker starships. Perfecting the transfer of hundreds of tons of cryogenic propellant between two spacecraft is a massive technical hurdle SpaceX must clear. But the ultimate goal, the reason Starship exists, is the colonization of Mars. Elon Musk has laid out an ambitious plan for the first uncrewed cargo missions to Mars as early as 2026 to test landing capabilities and deliver supplies. If those are successful, the first crewed flights could follow in the next launch window, around 2029 or 2031. The long-term vision is to establish a self-sustaining city on Mars, which would require thousands of Starship launches to transport 1 million people and millions of tons of cargo. In the nearer term, Starship is set to completely upend the satellite launch market. With a payload capacity of up to 150 metric tons to orbit in its reusable configuration, it will drastically lower launch costs. This is essential for deploying the next generation of SpaceX's own Starlink Internet satellites, which are too large and heavy for the Falcon 9 rocket. Starship will feature a unique Pez dispenser-style system to deploy these new satellites. Beyond that, its capabilities open the door to launching giant space telescopes, modules for new space stations, and even point-to-point travel on Earth, promising travel to anywhere in the world in under an hour. Despite the incredible progress, the path forward is filled with challenges and controversy. Several major technical hurdles remain. The long-term durability of the heat shield tiles is still a work in progress, and as mentioned, in-orbit refueling remains one of the biggest unknowns. Then there are the environmental concerns. The Starbase facility in Texas is located near a sensitive ecological area, home to endangered species and critical habitats for birds. The first orbital test in 2023 caused significant damage to the launch pad and sent a cloud of dust and debris over a wide area, prompting a lawsuit from environmental groups against the Federal Aviation Administration, or FAA. The FAA, which licenses commercial launches, has been closely overseeing the program. Each test flight requires a license modification, and the agency has required SpaceX to implement numerous mitigation measures to reduce its impact on the local environment. Finally, Starship is being developed in a competitive and politically charged landscape. While SpaceX dominates the market now, companies like Blue Origin and United Launch Alliance are developing their own heavy-lift rockets. And NASA's reliance on Starship for its Artemis moon landing has raised questions about depending on a single, still-in-development vehicle for such a critical national goal. Delays in the Starship program could impact the United States' goal of returning to the moon before China. The Starship program, with all its fiery setbacks and monumental goals, represents a pivotal moment in the history of space exploration. It's a high-stakes gamble that, if successful, will unlock a future once confined to dreams. The road ahead is difficult, but the relentless pace of innovation at Starbase suggests the reusable revolution is coming. As these towering stainless steel rockets continue to rise from the Texas coast, they carry with them the collective hope of a species on the cusp of becoming truly interplanetary.